Welcome back to our fourth part of this video. In this video, we will learn how to display messages, numbers and sensor data on the LCD screen with our trainer kit. So, today's first activity name is LCD display activity. As we have seen in the previous video, we have seen some numbers, some messages and sensor data on the LCD screen. Now we will see how it works. This activity is all about the LCD display, a simple but powerful way to show information in the embedded system. Instead of just blinking LEDs, now we can actually see text, numbers and live sensor readings right on the screen. So, to understand how to interface an LED with an microcontroller and display customized messages or data. So we need components for this activity. This is LCD 16:2 display. This is microcontroller Arduino Mega 2560. We have used potentiometer. The working principle of this activity is the LCD is like a voice of your project. It tells you what's happening inside the system. The microcontroller sends characters in the binary form. The LCD driver decodes those signals, and finally you see readable text or numbers appear on the screen. So you can print welcome messages, sensor values and even live system status. Now we will do coding for this activity. Here is the code for this activity, and these are the pins for liquid crystal LCD display. So in this activity we will also select the board, select the port and upload the program. The procedure is same for all these activities, and the code is given in the description. After uploading the code, we will see the techno word on the LCD display. If we change the code, we can make it show sensor values like temperature from DHT11 sensor and soil moisture levels. The best part is it is reusable in almost every project. So from this activity we have learned how display brings interactivity to embedded systems. Instead of guessing, we can now monitor and debug our projects in real time. This is the same principle used in washing machines, microwaves and even in ATMs. So, and that was our LCD display activity, giving your project a screen and a voice. Stay tuned as we connected sensors and make this display truly dynamic. So this is our first activity of this video, LCD display activity. Now it's time to do our second activity, which is 4-digit 7-segment display activity. Ever seen digital clocks on counters? They run on 7-segment displays. So today let's learn how to control a 4-digit display with our trainer kit. This activity is about 4-digit 7-segment display, which allows us to show numbers from 0000 to 9999. Unlike a single LED, this display can represent multi-digit values, making it perfect for clocks, timers, counters and measuring devices. To understand how microcontroller drivers a 4-digit 7-segment display and how multiplexing is used to control multiple digits efficiently. So components required for this activity is 4-digit 7-segment display. This is microcontroller, registers for current timing, and now we will see working principle of this activity. The 4-digit display is made of 4 individual 7-segment displays that share common pins. Since the microcontroller doesn't have enough pins to drive all segments directly, we use a technique called multiplexing. And here how it works. Only one digit lights up at a time. The microcontroller switches between digits very quickly because of persistence of vision. Our eyes see all 4 digits glowing continuously. This makes it possible to display numbers like counters, temperature or timers with minimal hardware. After uploading the code, see the display is showing some numbers. If you update the code, it can act as a countdown timer, a stopwatch or even a digital clock. From this activity, we have learned the concept of multiplexing and how large numerical data is displayed using fewer microcontroller pins. This is exactly how calculators, clocks, weighing machine and fuel dispenser shows numbers. And that was our 4-digit 7-segment display activity. Turning simple numbers into a live digital display. Stay tuned as we move to more advanced sensor-based project. Now let's move to our next activity, which is Bluetooth control activity. In this activity, we will learn how to connect Bluetooth module like SC05 or SC06 to our trainer kit. This allows our microcontroller to communicate wirelessly with a smartphone, tablet or laptop. It's one of the easiest way to bring wireless control and monitoring into your projects. So, to understand how Bluetooth enables wireless communication between the microcontroller and a mobile app or terminal and to control devices remotely. So, we need for this activity the Bluetooth module SC05, the microcontroller on the trainer kit, a smartphone with Bluetooth terminal app and wires for interfacing. The working principle of this activity is the Bluetooth module works on wireless serial bridge. The smartphone sends command over Bluetooth. The Bluetooth module passes to the microcontroller through UART, TX and RX pins. The microcontroller interprets the commands and performs actions like turning on an LED, controlling a motor or sending back to sensor data. It's just like texting your project and it obeys instantly. So we will see in this activity how it works. The app, which is serial Bluetooth controller app. When I open the app, here is given connect the Bluetooth from here, the SC05. When connected, it shows on the screen. Then after this, send a message. This message is look on the screen. So when I put some message on the screen, it will show on the LCD screen. Look at this. And with this, we have successfully completed all 12 activities on our educational trainer kit. From basic sensor interfacing to advanced modules like Bluetooth This is a complete hands-on solution for learning Arduino and electronics in a practical way. Stay tuned for more innovative projects and tutorials. Don't forget to like, share and subscribe for each more tech learning.